Why did the Chicxulub asteroid, the one that wiped out the dinosaurs, cause such wide-scale catastrophe and extinction for life on Earth when there have been hundreds, if not hundreds, of other similarly sized or larger impacts that haven't had that scale of destruction? The answer, to start with, yes, Chicxulub-sized impactors are common enough on a geologic timescale that we generally need to start looking for what made the Chicxulub impact special. Specifically, on average, Chicxulub-sized impactors would be expected to hit Earth every 30 to 100 million years, with the 30 million year recurrence end of the range probably more likely than the 100 million year recurrence, e.g. Grieve and Shoemaker, 1994, but there are not mass extinctions on the scale of the KPG with the same average rate of occurrence. The specialness of Chicxulub could be one of two things, or some combination of both. 1. Location. As discussed by Kaiho and Oshima 2017, there's a broad idea that much of the ecological devastation caused by the Chicxulub impact came down to the rocks it hit, specifically a sulfur-rich carbonate platform. At the time of impact, only 13% of the Earth's surface contained similar rocks, so it's possible there would not have been an extinction if the Chicxulub impactor had hit any of the other 87% of the Earth's surface. This also means that when considering the probability of an impact causing an extinction, we need to factor not just recurrence of a given sized impact, but also recurrence of a given sized impact hitting the right type of rocks. 2. Coincidence with flood basalts. There's generally a vigorous debate about whether the impact or Deccan Traps volcanism was more important in the KPG extinction. One thing that comes out of this is that there's a long-standing idea, bolstered by recent results, that neither the Deccan Traps or the Chicxulub impact were sufficient on their own to cause the extinction, but together they could, e.g. Peterson et al. 2016. Thus, again, considering the probability, we have to think not just about the recurrence interval of a Chicxulub-sized impactor, but the probability of a Chicxulub-sized impactor hitting while a flood basalt is erupting, e.g. White and Saunders 2005. If we take both arguments at face value, we can start to see that even with a Chicxulub-sized impact every 30 million years, in order for such an impact to actually cause a mass extinction, it needs to potentially hit the right spot on Earth and at the same time as other climatic disruptions, like the eruptions of large igneous provinces. The probabilities and thus expected average recurrence of all of those together are significantly lower, a longer average recurrence, than just the probability of a Chicxulub-sized impactor hitting Earth. Follow this channel for more Santa Explains. And if you have any questions I should answer, just write them down in the comments.